Hey everyone and welcome back to the channel. Ever wonder how economists make sense of the world, predict things like inflation, or figure out if a new policy will actually work? Well, a big part of their toolkit is something called econometrics. Now don't let the fancy name scare you. Econometrics sounds complex, but at its heart, it's just a super cool way of combining three things: economics, mathematics, and statistics. Think of it like this. Economics gives us the theories and ideas about how the economy works. Mathematics helps us write those ideas down in precise equations. Then statistics gives us the tools to test those equations using real-world data. So, in simple terms, econometrics is about using statistical methods to analyze economic data, test economic theories, and even forecast future economic trends. It's how we move from "I think this is true" to "the data suggests this is likely true." Let's make this super concrete with an example we can all relate to. The relationship between education and income. Common sense and economic theory tell us that generally, more education leads to higher income. But how much higher? Is it always true? Econometrics helps us quantify this relationship. Imagine we collect data from 100 people, their years of education, and their annual income. If we plot this data, we might see a general upward trend. Econometrics helps us draw a line of best fit through these points. This line represents the average relationship between education and income. Income is V0 plus V1. Education plus... Looks a bit mathy, right? Let's break it down. Income. This is what we're trying to explain. Our dependent variable. Education. This is what we think influences income. Our independent variable. Our V0, beta naught. This is the intercept. It's the estimated income when education is zero, though often not directly interpretable in these contexts. Our V1, beta 1. This is the most interesting part. It's the slope. It tells us how much income is estimated to change for every 1 unit increase in education. Epsilon. This little guy is the error term. It captures all the other factors that affect income but aren't included in our simple model, like job experience, natural talent, luck, etc. Now, here's where the numerical example comes in. Let's say after running our econometric analysis, we get these results. This equation tells us the estimated base income with low years of education, though again, interpretation needs care, is $15,000. For every additional year of education, a person's annual income is estimated to increase by $5,000.